Let's look at a basic inheritance tree of different objects. You probably have some code that looks similar to this, where you've got something more generic up at the top, like for example, vertebrate, and then as you go down levels, things get more and more specific, such that at the very bottom is your most specific level. Well, in some inheritance trees, as things get more generic, they kind of stop making sense as actual instances of objects. Like, what is a fish object? There's so many different types of fish, that's too generic to really exist in the wild. So, how do you make sure that you're relating things appropriately and sharing code, but still making it clear, hey, this is not a class that I actually want you to implement? That's where something called abstract methods come in. Abstract methods are a method definition in a superclass, but they have no actual implementation. It's just the method header. What this is a contract between the superclass and the subclass. As the superclass, I'm dictating what the subclass has to actually implement. In order to do this, you put the keyword abstract and then a method header, just like you would. So you can have the return type and the parameters. You also don't need to set public or private because you'll decide that in the subclass. As soon as you have any abstract methods in an object definition class, you have now created an abstract class. So if you have the abstract keyword anywhere inside of that class, you've got to add it to the class header. Now what you have is you have something in your inheritance tree that can share code with child classes, but is also working to guarantee the behavior of child classes. So you're setting up a hierarchy where you have generic classes up near the top that are saving you redundant code, but are also creating strong relationships between the parent classes and the type of behavior that you know you need to see in the children classes. Let's look at our tree from before. So we have 4 very specific classes on the bottom, and then we have 2 separate levels representing 3 separate classes of kind of generic things that don't really make sense in the real world. By adding abstract methods to these classes, we can guarantee the behavior of our children and sort of define these as classes you don't really want an instance of. This is going to save us a lot of work in sharing code, and it's also going to create very strong relationships within our inheritance tree, which sometimes can come in pretty handy. So you might be wondering, okay, it's a contract between one piece of code and another piece of code. That sounds a lot like an interface. So when do you use an abstract class and when do you use an interface? Well, ultimately, an abstract class is just a regular superclass that you're adding in some guaranteed behavior to. It's like adding a little bit of an interface to an existing superclass. So now you can both share code and guarantee behavior in really closely related classes. And that's the key. When you have classes that are really well related, you want them to have these strict relationships. You also will probably want to use an abstract class when you have specific subclasses that need to extend really general and thus sort of impossible classes. You know, if you have a structure of different employees, chances are nobody has the title employee. They probably have something much more specific. So maybe employee is an abstract class and its subclasses are things like teacher or principal. Instead, when you want to use an interface is when you want to relate not on the actual parent-child kind of relationship, but on the behavior. So this is how you guarantee behavior across pretty unrelated classes. So for example, how do you guarantee my behavior to a data structure that might contain instances of that object? You'll also maybe want to use inheritance when you've exhausted your basic inheritance and your abstract classes. Then you can use interfaces to add in relationships because you know you can always add in as many interfaces you want, but you can only ever extend one parent class. Now you've got a whole toolbox full of different ways that you can form relationships between pieces of code. And this becomes incredibly important as your code pieces get bigger and more complicated. Because the better you can define the relationships between your pieces of code, the easier it's going to be to add things into your ecosystem and for other developers to understand exactly what work you're doing.